Alrighty, YouTube, welcome back. Viewers, here's my next video. My next step is to build a clock for my computer so that we can use it to make the computer do things all by itself, kind of. So the way to do that is to build something called an Astable Multivibrator. There's several ways you can do it. You can use a 555 timer. I'm using 2 transistors because I'm building a computer out of transistors, right? And a couple of capacitors and some resistors. Took me actually a little longer than I thought. You know, I could just build circuits that I saw other videos for, but I wanted to figure out the RC time constant so I could figure out what frequency, and it took me a minute actually to figure that out by reading a little bit. And so anyhow, I'll show you what I got. Hang on a sec. Okay, so here's the circuit that I built. It's a pretty simple little circuit. Let's go through it. We got a couple of transistors, 2 capacitors, 2 LEDs, and the LEDs are really just to show what's happening. You can see them turn off and on. And then 4 resistors. I saw how this happens, but basically the cap charges and then charges enough to close this one, turns the LED on, then this one charges enough to turn this one off and turn this one on, and it just flips back and forth. And that's why it's called Astable Multivibrator. Like, there's no stable state, right? It flips back and forth. Anyhow, this is what I built. A little circuit here. Here's the formula that I used that I could find. I don't know where the 1.38 constant comes from. Somebody may let me know in the comments. But that's what I found, the frequency. And so I'm trying to use components I have, right? So I have these 2 10 microfarad electrolytic caps already, and then I figured I could just get a resistor value close enough. So what I did here is used 1K resistors over here just to current limit the LEDs, right? And the 2 inner resistors determine the RC time constant that determines how quickly it'll turn off and on, right? Charge and discharge. So using this formula, I know my 10 microfarad caps, I went with I think I originally calculated like a 50K resistor. So these are actually 5.6K resistors is what I had in my bag of resistors. And so I calculated it was supposed to be 1.4 hertz or something. Hang on a second. Let me calculate it again. Okay, yeah, I came up with 1.29 hertz using the 56K resistors. Doing 56K times 10 microfarad cap times 1.38, divide all that by 1. So it should be just under 2 hertz. So let's fire it up. And yeah, I mean, it seems like, I don't know if that is per LED, right? So if we disregard this one, is that just over 1 hertz? It seems like it. Right around between 1 and 2 hertz, between 1 and 2 times a second. It seems like that's about right. It should be, right? So the formula should be pretty close. Because I had a 330K ohm in here before, and it was like really slow. It was like, I don't know, 1/4 of a hertz or less. And then I reduced the resistor value, so the capacitors are going to discharge faster and flop back and forth faster. Anyhow, so there you have it. This will be a quick little video. My next one will build on this. And I have some other pretty cool things lined up. I'm thinking about, instead of my binary output, I'm thinking about making a transistor version of a 7-segment display driver, so that instead of binary, you can see a 7-segment display, and then possibly even making my 7-segment display out of discrete LEDs. That'd be kind of cool, right? So anyhow, stay tuned, and we'll catch you on the next one. Have a good one.